Okay, kids, so today we are doing lesson 8.5, proportions in triangles. You will have homework pages 448 to 449, numbers 2 to 21 all. It's 19 problems, but it's pretty simple stuff. So, all right, let's go ahead and get started. So remember, this is a recording, so obviously you guys can stop the video and take notes, write down the problem, all that good stuff, and then listen to it over and over again if you don't understand something, or if you just want to hear my pleasant, beautiful voice. And I know you guys are missing me right now. So, but before we do that, let's go ahead and do a review problem from 8.4. Okay, so here's a problem involving geometric mean. How do I know that? Well, here I have a triangle right here. You see this little triangle, and it's actually supposed to be a right triangle. Sorry about that. So this is a review of 8.4, but let's write this down because I want you guys to still be able to do this kind of work. So here's the right triangle, and there's an altitude that has been that's splitting the right triangle into two different right triangles that are also proportionate. So make sure you look at your notes for this stuff because I want you guys to do well on this on your test. But here we go. So again, this is right here the hypotenuse of the big triangle right here, and this is the altitude that's splitting the hypotenuse into two segments. You can see small little triangle here, and the medium triangle, and then the big triangle. What's important to remember is that all three of these triangles are similar to each other. Since they're similar to each other, we know that the altitude right here, where this y is, the altitude is actually the geometric mean of the two segments. This segment right here, and this segment right over here. So how would I set this up to find out y? Well, this is what I would do. Okay, you would do the geometric mean. So you would do, this is pretty much over here going to be your a, so you got to figure out, this could be your a, this could be your b, and then this could be right here your x, even though you have another x right there, but we'll just pretend this is x for right now for geometric mean purposes. So if we know that this is a geometric mean, then you know that this is a and b. However, a doesn't have a number because this whole thing is 30, but we know that if we do 30 minus 6, we'll get this segment to equal, what is it? That's right, class, 24. Let me write that down. Okay, here we go. So let's set it up. Remember the geometric mean, we write a over x equals x over b. Okay, so here our a is going to be 24 over, we said x is already y, right? Equals y over 6. So we know if we cross multiply, y times y is, oops, wrong one. Y times y is y squared. 24 times 6. This is where I get my calculator out. And I say, what is 24 times 6? I'm like, right, 24 times 6 equals 144. Oh, easy, because we know that the square root of 144 is going to be 12. So you square root it, y equals 12. Great. So we have y equals 12. Now, what I would then do, oops, why did I put y equals y? I meant y equals 12. My bad. Hold on 1 second. All right, so y equals 12. Let's go back. There we go. All right, y equals 12. That's a weird looking 12. There we go. All right, so y equals 12. So now I have this is 6 and this is 12, and I still have to find out what x is and what z is. Now, this is what I would do. Do you see that you have here two sides of this right triangle and then two sides of this right triangle? Well, you know that Pythagorean theorem says that if I have two sides of a right triangle, I can find the third side by using the theorem a squared plus b squared equals c squared. So that's what I'm going to do. Okay, so let's do this first, this little one right here. This right here. Okay, I know that this leg is 6, so that'll be my a, so 6 squared plus, this is my 12 right here, it's going to be my b, so this is 12 squared, is going to equal z squared. Okay, 6 squared, 36, 12 squared is 144, equals z squared. Okay, so then 136 plus 144 is 180? Yeah, it's 180. And then you got to square root 180. And obviously 180 doesn't have a perfect square root, so you have to break it down. So let's break it down. Let's go a little further down. So 180 breaks down to, let's see, 18 and 10, right? Which this breaks down to 9 and 2. This breaks down to 3 and 3. And this breaks down to 2 and 5. So if I get a different color over here, I see that I have a pair of 3s and a pair of 2s. So put those come out together and it comes a 6, right? Because 2 times 3 is 6. When on the inside all by itself is that little lonely 5, so 6 radical 5. So 6 radical 5 is going to be the square root of 180, and that's going to equal my z. Radical 5. Okay. Now I have 12 as this guy and 24 as this guy, so then I'm going to go ahead and figure out what x is by doing Pythagorean theorem. I'll do that one in this green color on this side over here, so down here. So I have 12, again, 12 can be A, 12 can be A, and 24 can be B, it doesn't really matter. But I'm just going to do again, I'm just writing down A squared plus B squared equals C squared. So you don't forget, we're having two sides of the triangle and we're solving for the third side by a simple Pythagorean theorem. Now we could also use the different proportions, but this is something I know really well, so I'm going to do this. So 144, 24 squared, this is where I use the calculator because I don't know what 24 squared is. Let's see, so 24, not letting me write. Oh no, close it. I don't want the ink layer here. Oh, my bad. Hold on one second. All right, 24 times 24, you probably already found it because you're like, Erica's taking forever on this, and you get 576. Great. So this is 576, and you add them together, plus 144. Yeah, I'm being a little lazy here. And it's going to equal 720. So c squared will equal 720. And you got to find the square root of 720 because in order to undo c squared, you have to square root it. Extend that page. 720 is really 72 and 10. This guy is 2 and 5. This is 36 and 2. And I'm going to stop here because I know that 36 is really 6 and 6. I'll not stop it. I'm not going to go further with 6 and 6 because I know that's a pair and that's a pair. So take one out of each. So 6 and 2 equals a 12. And then the 5 goes on the inside right here. So then my z, which is what I was solving for, was the hypotenuse. Take that guy out. My hypotenuse is going to be 12. Oh, not hypotenuse, I'm sorry. The long leg is going to be 12. Radical 5. And there you go. There you have it. If you want to see the whole big picture, I can show it to you right there, full screen. Okay, what we did is we first found the geometric mean of this guy, okay, and then we, by doing a over x, x over b, 24 over y, y over 6, we found it was 12, and then we just did Pythagorean theorem to find out this guy over here and this one over here, which is pretty simple, with 24 and 12 as a and b, and then 6 and 12 as a and b. All right, great. So now that we did our review, and that didn't take long at all, just like 9 minutes, but let's go on to the next thing because we got to go on. All right, so this is where you probably want to stop. Let me get this guy out of the way. Probably want to stop the video right now and take notes right here. You want to go ahead and talk about, or I'm sorry, write down 8.5 side splitter theorem and write this lovely theorem down with these two examples. Okay, go ahead and do that right now as you are, whoops, one second. Do that right now. Okay, so I hope you are able to get that. It says here the side splitter theorem is if a line is parallel to one side of a triangle. So here we go. We have a line here and it's parallel to this side. How do I know? Remember these little guys, these little squiggly lines right here, the little arrows? Those show that two line segments are parallel. And it says here, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So it's saying this, these two lines okay, are parallel, and they hit the edges of this of these two sides of the triangle, meaning it splits them up proportionally. So it's actually pretty basic. It's pretty simple. You guys already know proportion, so this should be pretty easy for you guys. So I'm going to go ahead and show you right here how we would split up, or write this proportion. So pretty simple here. Let me go ahead and entire page. Okay, let's go ahead and do this. So this proportion would look like this. You would take x. So here we go. We'll do this in blue. You're going to take x, and that would be over the 16. And it'd be equal to 5 over, can you guess? 10, right? So, oops, that looks like a 16. That's a little better. All right, so we just took x, put it over 16, and it's equal and it's proportional to 5 over 10. So you guys can figure out, okay, if 5 is half of 10, what is x going to equal here? You're right, x is going to equal 8. Or you could have cross multiplied and said 10x is equal to 80, divided it, and still gotten x equals 8. You guys know how to do that, so I'm not going to show you how to solve proportions. If not, make sure you ask for help on that. Okay, same thing over here. Okay, let's do this one in red. Okay, if I'm going to set up the proportion, I can set up x plus 1.5 all over x, and it's going to be equal to 5 over 2.5. And then again, you guys know how to solve this. You would solve it by proportion. So it's really simple. You just got to know a side splitter. One line is parallel to the other, and it has to say that it's parallel. Then it divides these sides up proportionally. Okay? All right, so let's go ahead and do some homework problems. This is right here. Solve for x's number 1 and number 2. I believe you have to do, like I said earlier, 2 through 21 all. So 1 is more like an example, and 2 is going to be homework. So let's do 1 real quick. 8 over 10. Oops. It's going to be 8 over 10, and it's going to be equal to 6 over x. Okay, so we're going to cross multiply, right? I'm going to take my little highlighter. Let me see, highlighter. Gotta love this. Highlight that, because I'm going to multiply 8 times x, and then I'm going to multiply 10 times 6. So let's get my pen back. So let's do this. Oops. 8 times x is going to be 8x. My pen went black all of a sudden. Equals 6 times 10, which is 60. Okay, divide by 8. All right, x equals, well, I know I can divide these two by 4, and I'll get 15 over 2, or also known as 7.5. And it's okay. You can say 7.5, you can say 7.5, you can even leave it as 15 over 2. It's all the right answers. Okay, that's great. So that's going to be, again, the example. Now, some people might even write 8 over 6 equal to 10 over x. And guess what? You're going to get the same thing. You're totally going to get the same thing, right? You're still going to get 8x equals 60. So either way, you're going to get it correctly, okay? You could do 8 over 6, 10 over x, or 8 over 10, 6 over x. Either way is correct. All right, now this is number 2. This is homework. Let's do this in a different color. Let's do this in green. Okay, so here we go. So here I have x plus 4. Put that over 2 equal to 9 over 12. Okay, cross multiply. 9 times 2 is going to be 18 equals 12 times x plus 4. I'm going to do 12 parentheses x plus 4 because I have to distribute that 12 to everything. So this becomes 18 equals 12x plus 48. So we have enough room. There we go. And then subtract 48 from each side because I'm going to get x by itself. 10 minus 48, you got it right, it's going to, or I'm sorry, 18 minus 48 is going to be negative 30 equals 12x, which I'm doing something wrong here. 12x equals, oh, I missed something wrong. Yes, you're probably right. I did this wrong. There should have been an x there. Way to go. I know someone already caught that probably earlier. Whoops, a daisy. Whoopsie, Erica. Okay, let's erase this. We need to go back to this. This is where I made my mistake. And yes, I will admit that I made a mistake. I don't like to admit it, but I did. 18x, sorry, my bad. Because it's 9 times 2x, it's an 18x. And it's 12 times x is 4. So I'm glad whoever caught that mistake. That was really good. So this is still 18x equals 12x plus 48. That's still going on. But then I would subtract 12x because I have to subtract the like terms. And I would get 6x equals 48. And then I would divide each side by 6. By 6, and I would get x equals 8. There we go. All right, that's a lot better. Whew. Okay, so those are the two examples. A pretty simple idea. We're going to review the notes for this. Put this on your little 3x5 note card. Study it. And let's move on. It's still 8.4. There's another theorem, though. Corollary to theorem 8.4 is if 3 lines are parallel, so I have, here we go, 1, 2, 3 lines parallel. Do you see that? Little sign means are parallel. And they're intersected by 2 transversals. I got a transversal right here and a transversal right here. It's really simple. Then the segments intercepted on the transversals are proportional. A to B equals C over D. That's it. So why don't you go ahead and stop it, write this down, and yeah, again, pretty easy. Okay, so let's move on to doing some of the actual problems. All right, here we go. So here we have, these are for problems number 4, 5, 6 through 7, which you have to do all of them. And they're pretty simple. They're pretty basic. And I'll just go ahead and run you guys through them. And here we go. So the first one here, we'll do number 4 together. Okay, and it says A over B equals blank over E, which I think we can pretty much figure. Let's see if we can figure this one out. I'll put this in a different color. Okay, so they're saying A over B, so this side over here over this side is going to be equal to blank over E, which I think we can figure out it's going to be this D here. So it's going to be A over B equals D over E. Pretty basic, right? And that's it. Let's do another one together. Let's do number 6 together. Okay, number 6 in green says F over E equals C over blank here. Okay, so let's do this one in black. Okay, so it's pretty, again, basic. We have F going from F to E and C, and you're right, it's going to be to B. So it's C over B. And that's it. It's pretty basic. So you solve this like that, and then you solve the proportions and the problems such as 8, 9, and 10. It's super simple. Okay? All right, let's move forward to the last corollary. Oh, it's a theorem, sorry. It's called the triangle angle bisector theorem. Go ahead and write that down before I start talking about it. Okay, so here we go. It says if a ray, here remember a ray is has an endpoint and then it goes on forever with a little arrow there. If a ray bisects an angle, bisects, if you forgot what bisect means to what? It means to cut in half. I hope that looks like it. Ugh. Okay, it's all right. Means it cuts it into two congruent angles. Okay, so the ray cuts into two congruent angles. Then it divides the opposite side into 2 segments that are proportional to the other sides of the triangle. Again, it's all about proportions. It's really easy. And so again, this ray here, when we have to have a ray and it has to show that it bisects it. Remember, this is one little hash mark, another little hash mark. Okay, bisects it means that it cuts it in half. That means that this x is going to be proportional to 6 and 8 will be proportional to 5. Just like that. x over 6 equals 8 over 5, and we can cross multiply and say, okay, well, this, when we cross multiply, will get me 5x. 6 times 8 is 48. Divide by 5. Divide by 5. X will equal, let's see, x goes into 48 9 times. And how many left over? 3 left over, 9 3/5, which if you guys don't know how to convert 3/5 is really 0.6, so this is really 9.6. Okay. Alrighty, pretty simple stuff. Again, it's all about proportion. It's knowing, though, these different theorems. So what I would do, write these theorems down, write in your note card, study it. This is stuff that you got to know because there's a lot of theorems coming down on this test, but I think you guys can do this well. All right, here we go. How would I set up this proportion? Well, I see here that this ray or this line cuts this angle into 2 equal congruent angles. So that means that this will be proportional to this and this to this. So I can write this proportion actually 2 ways. So what's way number 1? Way number 1 would be this. I could say, well, 8 over y is equal to 5 over 3.6. Okay, 8 over y is equal to 5 over 3.6. Pretty simple. Or second way would be 8 over 5 is equal to y over 3.6. Pretty simple. And then you would solve by cross multiplying. That's right, cross multiplying. Okay, easy peasy lemon squeezy. All right, let's go on to some problems for your homework. So this is part of your homework here, 11, 12, and 14. We'll just do a couple together and then we'll be done with this lesson. And it's only 22 minutes. Okay, so here we go. The triangle angle bisector theorem. So I want to solve for this x. How would I solve or set up the proportion? Pretty simple, 10 over 5 equal to 12 over x. I would get 5 times 12. Put on this side 60 because the variable is over here at 10 times x. 10x. Oh, and x would equal 6. Very simple. Why don't you try setting up these two before I start them and solve them, and then play me back and then see if you get it right. Okay, so go ahead and try doing these on your own. Okay, so let's go ahead and try some of these. All right, so I'm going to do this way. Let's do 5 over 8 equals 3 over x. And remember, I know this works because I have 2 equal angles. So I know 5 times x is 5x. 8 times 3 is 24. X is going to equal, 5 goes into 24 4 times with 4 left over. 4 and 4/5 is the same as 4.8. Okay, let's put that dot right there. Okay, so here, this might look a little weird because this whole thing is 6 and this little part is x. And like, how am I going to get this part? Well, this part is actually pretty simple because if you think about it, it's the difference between the 6 and the x. So I would just write this little part as 6 minus x. And you can still use that as part of your problem. So this guy is going to look like this. Now, again, remember, I can set up the proportion 6 over x or 6 over 4. But as long as I just set it up the same way each time, I'm fine. So let's do it this way, because last time I did 5 over 8. I can still do this way, 6 over x. So we'll do 6 over x is going to equal 4 over, remember, this is the difference of 6 and x, so 6 minus x. So this is pretty simple here, 4 times x. 4x equals, I'm going to distribute the 6 to the 6, which is 36. And I'm going to distribute the 6 to the negative x, which is negative 6x. I'm going to add 6x to each side. I get 10x equals 36, and I'm running out of room, so I'm going to extend that page. Divide by 10, whoops. x equals, now 10 goes into 36 3 times with 6 over 10 left over. However, that fraction really becomes 6/10, or also known as 0.6, because 6/10 is the same as 0.6. All right, and that is how we do the triangle angle bisector theorem. So this is it for this lesson for 8.5. Make sure that you guys go through these again. If you're having trouble, ask for some help from Arlette from tutoring. But the homework is pretty simple, and I did a few of these problems with you, so you shouldn't have much left. Study it, review it, and all right, on to the next video.